Hi y'all, in this video we're going to discuss De Morgan's laws. On the sheet that goes with this video, you should have truth tables for each of the following four compound statements up here. Take a moment, pause the video, and fill in the truth tables yourself. And when you come back, we'll continue from there. With the truth tables filled in, hopefully you'll notice a couple of things here. If we look at the compound statement in A and the compound statement in C, and compare their final column in the truth table, we should see that it's exactly the same. Alright, again, false, true, true, true. False, true, true, true for both A and C. What that means is we will say those two statements A and C are equivalent. When I look at B and D, comparing the last column in each of the truth tables for B and D, I see those are also the same. Those being the same, again, is going to imply that B and D are equivalent statements. And that's what we're going to mean when we refer to De Morgan's laws, is the fact that those two things are equivalent. Those two sets of compound statements are equivalent. To reiterate, what De Morgan's law says is that the negation of the quantity P and Q is equivalent to the negation of P or the negation of Q, along with the fact that the negation of the quantity P or Q is equivalent to the negation of P and the negation of Q. As discussed earlier, this effectively gives us a way to distribute negation across these parentheses. And this idea extends. That is, I can use this on other things with parentheses. For instance, if I have the negation of P or not Q, this is the negation of P and Q. What happens here, one way we can think about this is I'm negating each of the parts here, the individual parts within the parentheses. The negation of P is not P. The negation of not Q is Q. And flipping the sign. This went from an or to an and. This only applies, this rule of De Morgan's laws, the rules with De Morgan's laws only apply to things with ands or ors. Alright, so there's one example, similar examples would follow along from that. Now let's look at an example of using De Morgan's laws. In this example, we want to use De Morgan's laws to write the following statements, statements that are equivalent to the following. So the statement I'll first consider is the statement, it is false that McDonald's has good salads and Sonic has good shakes. To do this, I'm first going to pull out individual simple statements. And looking at this, I see a statement here, McDonald's has good salads, let's call that P. And a statement here, Sonic has good shakes, let's call that Q. I see this connective and I see this it is false. I need to account for those. So in symbols, this it is false should be the negation of something in parentheses. I got the P and Q. So this should be equivalent to, well, using De Morgan's laws, the negation of P or Q. I'm sorry, the negation of P or the negation of Q. Again, the idea with this is that I can extend this negation to P. That gives the negation of P, the negation of Q, and it flips the sign. That is, it goes from an and to an or. Alright, so I should see that an equivalent statement should look like this. So I'm going to write the negation of P, that is, McDonald's does not have good salads. This is the connective or the negation of Q here should be Sonic does not have good shakes. Again, what we've just done is we've written two equivalent statements. That is the statement, it is false that McDonald's has good salads and Sonic has good shakes, has exactly the same logical meaning that the statement McDonald's does not have good salads or Sonic does not have good shakes does. Those two statements, again, mean the same thing. Looking at another example of using de Morgan's laws, let's consider the example Lady Gaga is a good singer, or the moon is not made of cheese. Again, I want to use de Morgan's laws to write an equivalent statement to this. So let's break this up. Lady Gaga is a good singer. Let's call that P. The moon is not made of cheese. We have a couple options with this. We can call this all by itself Q, or since this involves the word not, I can call this the negation of Q. Typically in examples like this, I choose to call this the negation of Q. It's actually not going to matter a whole lot either way what you call it here. We should end up with the same final result, but let's see how this works out. Alright, so I start with the statement P or not Q, and I want to write an equivalent statement. So this should be using de Morgan's laws. The negation of, well, inside those parentheses I'll have to have the negation of P. It's going to flip the sign, and I want to have the negation of whatever I have right here. So it should be the negation of the negation of Q, which is Q. So de Morgan's laws tells me my final equivalent statement should look like this. The negation of the quantity, the negation of P and Q. What that's going to look like then is, well, to write out in words what this negation of a quantity is, I'm going to write it is false. That the negation of P should be Lady Gaga is not a good singer. The connective I want here is and. Now let's consider what Q would be. We said the moon is not made of cheese is the negation of Q. So Q itself should be the moon is made of cheese. And I think that's again another example of using de Morgan's laws to write actual equivalent statements. To reiterate, what we're saying here is that the Lady Gaga is a good singer, or the moon is not made of cheese, has an equivalent meaning, a logically equivalent meaning to the statement, it is false that Lady Gaga is not a good singer, and the moon is made of cheese. Have fun with logic.